Mesopotamians were the first to make long-term records about 4000 BC. They made the ziggurats, which were towers with 7 terraces: the Sun, Moon, Mercury, Venus, Mars, Jupiter, and Saturn. They were responsible for keeping track of the yearly cycle in which the welfare of the agricultural community was so dependent. Mesopotamian astronomers were able to do this because they had discovered that the group of stars that rises just before sunrise changes with the seasons. The pre-dawn rising of the constellations they call the bowl of heaven marked the beginning of spring. They originated the idea of dividing a circle into 360 degrees, dividing each degree into 60 parts called minutes, each minute into 60 parts called seconds. The sun's motion took 360 days annually. That was a problem because the actual year length was 365 1/4 days. So they made every other year 13 months long. In 4000 BC, the Egyptians started to develop a calendar used for predicting natural disasters such as the Nile flood. They also started aligning temples and monuments with the north, south, east, and west points. The temple of Amun-Ra at Karnak was formed with the rise and set of the sun at the time of the summer solstice. Aristarchus from 310 to 230 BC showed distance to the moon, size of the sun and the moon, and found the moon's angular diameter through a lunar eclipse. Also found the ratio of distance the sun to the moon by the angle between the sun and moon at the third quarter of the moon. He found out the sun must be 19 times the distance as the moon. Calculated the sun also has a diameter 7 times as large as the earth, which led the sun to stationary. Earth orbits around in a circular path around the sun. Stonehenge were a massive group of stones placed upright in a circle in England. The purpose for this is still unknown. The theory is that it was the work of ancient astronomers. 12,000 BC, the Chinese made observations of 900 solar eclipses and 600 lunar eclipses. They also recorded meteor showers known as guest stars and comets. They also observed the comet Halley dating back to 466 BC. In 585 BC, Thales was the first to predict the solar eclipse. He was also the first person to use the Little Dipper as a navigation aid. He measured height of the pyramid with lengths of the shadows. From 582 to 500 BC, Pythagoras developed the model of the solar system. He also assumed that celestial bodies move in circular paths. He also believed that the Earth was a sphere, to believe it was flat. He also didn't believe that the Earth was stationary. He believed that it moved around and that when it moved, it made a background noise due to its size. 500 BC, the Babylonians looked at motions in the moon and planets. They found each planet's synodic period, also measured longer intervals of time a planet took to return to the same position with respect to the stars and the sun. It occurs when multiple of synodic periods of planets is equal to the whole number of years. They gave them a way to predict the positions of the planets. They believed in astrology and believed the Earth and Sun and Moon caused floods. They started predicting life events in humans, which were called horoscopes. They also predicted lunar eclipses in 300 BC due to astrology. 384 to 322 BC, Aristotle accepted the model of Eudoxus, but he modified it to include even more concentric spheres. Aristotle argued that all celestial motions must be circular because circular motions is the only kind of motion that can be repeated forever and is suitable for unchanging bodies such as the moon, sun, and stars. One of the proofs proposed that falling objects move toward the center of the earth for a sphere that is perpendicular to the surface. Another proof argues that the shadow of the earth can be seen on the moon during the early and late stages of the total lunar eclipse, which is always circular. If the earth was flat, it would show like a disk on top of the moon. Another argument was if the earth was flat, then you could see stars from everywhere, but some stars could only be seen in Egypt and not in Greece. He also came up with the idea that the world is composed of the 4 elements: earth, air, fire, and water. The heavier elements like earth and water naturally move downward toward the center of the earth, while air and fire naturally move upwards. About 276 BC to 195 BC, Eratosthenes used geometry to calculate the size of the earth. He sent an assistant to Syene in southern Egypt to observe the altitude of the sun at the summer solstice. The assistant reported that the sunlight reached the bottom of a deep vertical pit at noon. This meant that the sun was directly overhead. Eratosthenes measured the sun's altitude at Alexandria to be 82.8 degrees. This meant that the difference in latitude of the two cities is 7.2 degrees. Circumference differed from the true value of 25,000 miles by somewhere between a few percent and about 15%. In 134 BC, he discovered a new star and made a catalog of the brightest stars, about 850 stars' positions in equinox brightest. He compared the positions with other stars earlier and differed by 2 degrees, most due to precision. He estimated that the precision shift vernal equinox by 1 degree every 78 years. With discovery of precision, the list of celestial motions were complete. In 1016, the Mayans aligned the buildings to position with the sunrise and sunset at the equinox and the solstices. Once they identified Venus, they aligned buildings and lines of sight pointing toward the northernmost and southernmost points of the rising of Venus. They were able to predict the risings of Venus and lunar and solar eclipses with extensive tables. They also made a complex calendar to track the rising and setting of Venus, the Sun, and the Moon. 127 to 151 AD, Ptolemy accurately accounted for the motions of the planets using combinations of regular circular motions. He also wrote a detailed summary of his pictures of the universe. The book also contained improved methods for finding the distance of the Sun and the Moon. And it also presents a catalog of more than 1,000 stars, giving their celestial coordinates as well as their brightnesses. He also came up with a system to find the brightness of stars, which is called a magnitude system. He completed the model of the solar system, which showed the motion of each planet and found the future position. The system is geocentric because the Earth is too heavy to move. The planets move on an epicycle, moves along a path called different. They produce looping motions, allows planets to move east, regular periods of westward. During westward movement, planets is nearer the Earth and brighter than normal. In agreement with brightness, observatory adjusted 3 factors: the size of the epicycle and different, speed of planets, the tilt of the epicycles. From 1473 to 1543, Copernicus created the heliocentric model, which was the Sun was at the center of the motion of the planets. The Earth's revolution about the Sun explains the annual motion of the Sun. The retrograde motion of the planets occurs naturally when Earth passes or is passed by the other planets. It also showed that with the synodic and sidereal period, it made it possible to use geometry to find the planetary distances. His theory was almost all right, except everything traveled in perfect circles. In 1571, Kepler came up with the 3 states of planetary motion. The first states a planet moves on an elliptical orbit with the Sun at one focus. An ellipse is a closed curve for which some of the distances from 2 fixed points are the same for every point on a curve. The second states a planet moves so that an imaginary line connecting the planet to the Sun sweeps out equal areas in equal intervals of time. A particular of planet, the product of distance from the Sun and transverse velocity is constant. The third relates the motions of all of the planets to each other, describes relationships between sidereal periods of a planet and its average distance from the Sun. In 1609, Galileo made his telescope of his own and immediately started doing observations on the stars, moon, sun, and planets. He saw that the stars remained the same, unlike everything else had. Galileo realized that the Sun rotated once about every 4 weeks because of its sunspots. He found the Moon had mountains, valleys, and plains like the Earth. The Moon is a celestial object. He discovered that Jupiter had moons and that they orbit Jupiter, which proved planets orbit the Sun and Earth isn't in the center of the universe. In 1832, he wrote a book about the structure of the universe. It had sides of the heliocentric and geocentric models. 1869, Armstrong and Aldrin were the first ones to land on the Moon. In 1923, Pauli came up with the Pauli principle, which states that 2 identical fermions cannot occupy the same quantum state simultaneously. Bohr was involved in quantum mechanics. He discovered the structure of the atom. In 1913, he created the Bohr atomic model. He also later studied the structure of the atom's nuclei, creating the liquid drop model of the nucleus. Heisenberg was involved in quantum mechanics, and he figured out you can't know the speed and where small things are. If you know one, you can't know the other. In 1909, he made observations with a telescope and discovered galaxies are all moving away from each other and the universe is expanding. He predicted what comets appeared, and the Halley's Comet was named after him in 1682. In quantum mechanics and came up with theory of relativity with protons with electrical current. He proposed the first idea of the Big Bang Theory. He also derived and explained relation between distance and precision velocity of galaxies. He explored consequences of an expanding universe and where it originated from an infinite point. He was part of the Manhattan Project and worked on creating atomic bombs. He also created the Bohr-Oppenheimer approximator, his assumption that the motion of atomic nuclei and electrons in a molecule can be separated. He created the theory of nucleosynthesis and rejected the Big Bang theory that the universe will always have existed. He accidentally discovered the cosmic microwave background radiation. It was a major development in physical cosmology. He improved observation techniques, translated Greek astronomy into Arabic, and named a few stars in the 1400s. He discovered the brightest star in the sky without a telescope and believed in the geocentric theory. He rejected the heliocentric theory and focused on stellar parallax, which is the annual apparent change in the position of a star. The first law discovered is an object remains at rest or continues in motion at constant velocity unless acted on by an unbalanced external force. If force is acted on an object, it produces a change in momentum of the other object in direction force is acted on. When one body exerts a force on a second body, the second body also exerts a force on the first body. Gravitation states every two particles in matter in the universe attract each other with a force that is proportional to the product of the masses and inversely proportional to the square of the distances between them.